Hello students, let us start the new chapter, chapter number 3, multiples and factors. First, let us study what are multiples and factors. Factors can be defined as a divisor that exactly divides the given number without leaving any remainder. Here I have taken the example factors of 12. They are 1, 2, 3, 4, 6 and 12. You take any one of it, children. If I take 4, if I divide 4 by 12, I get 4 threes are 12. I do not get any remainder. The remainder is 0 here. If I take 6, I get 6 twos are 12. Here again I do not get any remainder, but I get it as 0. So these numbers which divide 12 completely without leaving any remainder, these are known as factors of that given number. Now let us see what are multiples. A multiple is the product of a number and a natural number. In other words, multiples are the product of two numbers. For example, multiples of 5 are 5, 10, 15, 20. Here children, I will explain you all. If I have a number 8, and if I go on multiplying 8 by all the natural numbers, we all are familiar with what are natural numbers. The numbers starting from 1 are all natural numbers. So when I multiply 8 ones are I get 8, 8 twos are I get 16, 8 threes are I get 24. In short, I can say that multiples are nothing but the numbers which comes in the table of 8. Here I have shown you the example of multiples of 5. Now let us study the properties of factors and multiples. First, we will go with factors. The first property says that 1 is the factor of every number and every number is a factor of itself. That means 1 is always to be considered as the factor of every number because 1 divides every number. And every number is a factor of itself because when I divide 12 divided by 12, I'll get it as 1. So 12 is always divisible by itself. Property number 2. Factor of a number is always less than or equal to the number. Example 10, and the factors of 10 are 1, 2, 5 and 10. This means children, I will be getting the factors of 10 in between 1 and 10, where 1 and 10 are considered the factors of 10. I will always get the factor which is less than 10. Third property, every number except 1 has at least 2 factors and the factors of number are infinite. For example, if I take number 17, if I observe 17 does not have any factors but I have 2 factors. As we have seen property number 1, 1 is the factor of every number, so 1 is going to be the factor, and the factor of number is always and the factor of every number is the factor of itself. So here again 17 will be its own factor. So at least 2. Every number will have at least 2 number of factors, and factors of a number are finite. That means we can always count the factors. It is not infinite, it is finite or limited. Now let us see properties of multiples. The first property of multiple is every number is the multiple of 1 and every number is a multiple to itself. For example, 5 ones are 5. So every number is a multiple to itself and every number is a multiple of 1. Property number 2. Multiples of a number are greater than or equal to the number. Example 10. Again we have taken the same example, children. If I observe the table of 10, I'll get 10, 20, 30, 40. So here itself I can see that all my multiples of 10 are greater than 10. Property number 3. Multiples of a number are countless. That means infinite. We cannot count the multiples because we do not know that we all know that the natural numbers are infinite. So when I go on counting the natural numbers with a given number, I am going to get infinite multiples. I hope you are clear with the properties of factors and multiples. Let us see what are prime numbers, composite numbers, co-prime numbers in this slide. Prime numbers, numbers which have only 2 factors, that is 1 and itself, are called prime numbers. For example, 13 has only 2 factors, that is 1 and 13. What does that mean? That means the numbers in between 1 to 13 do not divide 13 completely without leaving any remainder. So none of them are the factors except 1 and 13. So it is known as a prime number. Composite numbers. Numbers which have more than two factors are called composite numbers. There are many examples of composite numbers. The few are mentioned as 4, 6, 8, 9, 12, 14, 15, etc. Co-prime numbers. If two numbers have only one as their common factors, then they are called co-prime numbers. If I take an example, 3 and 10. Factors of 3, I will get it as 1 and 3 because 3 is a prime number. Factors of 10 will be listed as 1, 2, 5 and 10. When I compare both the factors, I observe that 1 is the only common factor. So 3 and 10 are called co-prime numbers. In this slide, we will learn what are twin primes, even numbers and odd numbers. Twin primes, they are a pair of prime numbers that differ by 2. For example, 3, 5. 3 and 5, these both are the prime numbers and the difference between them are 2. So they are called as twin prime. The other example is 5, 7. Here again the difference is 2. 11, 13, difference is 2. So this kind of pair are known as twin prime numbers. Even numbers. We all are familiar with what are even numbers and odd numbers. Numbers which is divisible by 2 are called even numbers. Example 0, 2, 4, 6, 8 and so on. Odd numbers. Numbers which is not divisible by 2 are called odd numbers. For example 1, 3, 5, 7, 9 and so on. Let us learn what are perfect numbers. A number whose sum of all factors is equal to twice the number is called a perfect number. For example, 6 is a perfect number. Children, now if I list the factors of 6, I have 1, 2, 3, 6. When I add up the sum, I get 1 plus 2 plus 3 plus 6 as 12. Now, when I double the given number 6, I get 12. So, this is one of the example of perfect number. Note, 1 is neither prime nor composite number. It is unique number or special number. 2 is the only even prime number. All the prime numbers that you'll be observing, 2 is the only one even smallest prime number. Now let us learn about divisibility rule. The basic divisibility rules of the numbers you have already studied in class 4. Let us revise one more time. Divisibility rule for 2. The last digit should be even. That means the evens place digit should be 0, 2, 4 or 6. Here the example is 148. Divisibility rule for 3. The sum of the digit is divisible by 3. Example 7, 2, 9. When I add up the digits, I get 18 and 18 is divisible by 3. Divisibility rule for 4. The last two digits is divisible by 4 or 0, 0. Example 4000, example 1312. If you observe the last two digits, we have 0, 0 and 12 is divisible by 4. Divisibility rule for 5. The last digit should be 0 or 5. Divisibility rule for 6. Here a number is divisible by 6 if it is divisible by both 2 and 3. If I take the example 63180, I can observe that the ones place is 0, which is divisible by 2. And when I add up to the sum of 63180, it is divisible by 3. So I can conclude that 63180 is divisible by 6. Divisibility rule for 9. Divisibility rule for 9 is same as divisibility rule for 3. The sum of the digit is divisible by 9. Here the example is 7290 which sums up to 18 and 18 is divisible by 9. Divisibility rule for 10. The number ends in 0. Example 220. The digit in the ones place has to be 0 to be a divisible number for 10. Now we will see divisibility rule for 7. Here the example taken is 1274. To check if the number is divisible by 7, double the last digit starting from the ones place. When I double the number, I get 8. Subtract it from rest of the numbers. That means 127 minus 8 will give me 119. Now 119, when I check if it is divisible by 7, I check if it is divided by 7, I get it as 17. Hence, we repeat this procedure till we get a 2-digit number. But 119 was not possible when I double up 9. So, we directly divided by 7 to see if it was divisible by 17. We have taken one more example for divisibility of 7, 6, 7, 8, 4, 3. As you all can see, we have doubled up the last digit 3 and it turns to 6. That 6 we will be subtracting it by rest of the numbers 6, 7, 8, 4. I get 6, 7, 7, 8. Again I will be doubling the last digit 8 and I get 16. That will be subtracted from 6, 7, 7. I get 661. Again here the last digit is 1. When I double the last digit I get 2. So 66 minus 2 will give me 64, which is not divisible by 7. Let us see divisibility rule for 8. A number is divisible by 8 if the number formed by last 3 digit of the number is divisible by 8. Here the example is 4256. That last 3 digit 256 will be divided by 8 and I get 32. Therefore, the whole number 4256 is divisible by 8. Divisibility rule for 11. A number is divisible by 11 when the difference between the sum of the digits in the odd places and sum of the digits in the even places of the number is 0 or a multiple of 11. Let us take an example of divisibility rule for 11. Let us take the odd places starting from 4. Here, as you can see, the green arrows 4, 6, 3. I have taken the alternative number, that is number digits at the odd places 1, 3 and 5. When I add up, I get 13. The remaining digit at the evens place 9, 1, 3. When I add up, I get 13. The difference of the sum of the digit in the odd place and the sum of the digit in the even place is giving me 0. Hence, the number 496133 is divisible by 11.